One clogged vent lets the heating element hit 550 degrees and ignite trapped lint. No spark, no warnings. Just a normal-looking dryer slowly failing behind the wall. Here is exactly how it works. Most people assume a dryer fire means a broken machine or a bad wire. It usually isn't. Clothes dryers cause thousands of house fires a year, roughly 13,000 to 15,000 in US fire estimates. Those fires bring deaths, injuries, and hundreds of millions of dollars in property damage every year. And the trigger is boring. The single leading cause is simple: nobody cleaned the lint. So how does a pile of soft fluff turn into a wall of fire? Start with how a dryer is supposed to work. It's really three parts doing one job: dry the clothes and get the wet air out. First, a heating element, a coiled metal wire like the one in a toaster, glows hot and warms the incoming air. Second, a fan called the blower pushes that hot air into the spinning drum. There it soaks up moisture from your wet laundry. Third, that warm, damp air has to leave. It travels out through a duct behind the machine and exits at a flap on the outside of your house. Here's the part that surprises people. The heating element is supposed to run hot. Really hot. It isn't a gentle warmer. To dry clothes in under an hour, that coil runs at a high temperature by design. A thermostat switches it on and off to hold a target. When the air gets hot enough, the thermostat cuts the element. When it cools, the element kicks back on. So a healthy dryer isn't dangerous because it's hot. It's designed to be hot. The safety doesn't come from keeping the element cool. The safety comes from moving air. That flow of air past the element carries the heat away, into the drum, through the clothes, and out the vent. As long as air keeps moving, the heat keeps leaving, and everything stays in range. Stop the air and every one of those numbers changes. So what happens when the air stops moving? Now the villains. It looks harmless. Every time clothes tumble, the fabric rubs against itself and sheds tiny fibers. That soft gray fuzz is lint. It's basically shredded cloth, cotton, polyester, whatever your laundry is made of, broken into fibers so fine they float. And here's the thing about cloth fibers spread out thin and dry: they catch fire easily. Very easily. That lint screen in your dryer is doing real work, but it's not catching everything. A good chunk of lint slips right past it. The screen grabs the big stuff, and the fine fibers ride the airflow straight past it and into the duct. So where does the rest go? It goes on the same trip the air takes. Out of the drum, into the flexible hose behind the dryer, through the duct in the wall, and toward that flap outside. Except lint doesn't fly as cleanly as air. It snags. It catches on ridges, on bends, on the joints where sections meet. A little sticks with every single load. You dry one load and it's nothing, a dusting. But you run that dryer 3 or 4 times a week for months, and those dustings add up. The flexible hose collects a fuzzy lining. The duct narrows. The exterior flap gets caked until it barely opens. Nobody sees it happen because it all lives behind the machine and inside the wall. There's no alarm, no light, no signal. Just a slow, invisible buildup choking the one thing the dryer depends on. Which brings us to the dangerous part. What happens to all that heat when the air path gets squeezed? Here's where it gets dangerous. Remember, the airflow was the safety system. It's the thing carrying heat away from that glowing element. So choke the duct and you don't just slow the drying. You break the cooling. The blower still pushes, but the hot, damp air has nowhere to go. It backs up. Heat that should be leaving the machine piles up right around the element instead. Now the thermostat tries to do its job. It senses the temperature and cuts the element to cool things down. But cooling depends on fresh air moving through, and the air isn't moving. So the temperature falls slowly, if at all. The element cycles back on sooner and stays effectively hotter. With each block cycle, the baseline creeps up. The surface of that heating element climbs past its normal range toward 550 degrees Fahrenheit. Break time equals 0. 6 is slash, and here's the number that matters most. Lint doesn't need anywhere near 550 to burn. Dry, fluffy cloth fiber ignites at only a few hundred degrees, far below the temperature that overheating element can now reach. So picture the setup. You've got a superheated coil. You've got a duct packed with the most flammable version of cloth there is, dried out by months of hot air. And you've removed the airflow that kept them apart in temperature. The trapped lint sitting against or near that overheated metal doesn't need a spark. It doesn't need a wire to fail. It just needs to get hot enough, and now it is. It smolders, then catches. A fire starts inside the duct, in the one place you never look. But if it builds this slowly, wouldn't the dryer warn you first? Here's the good news, it does warn you. This failure is slow, and slow leaves a trail. The clearest sign is drying time. If a load that used to finish in one cycle now takes 2 or more, that's not the machine getting old. That's airflow dying. Choked air can't pull moisture out, so the clothes stay damp and you run it again. Sign 2, the top of the dryer gets hot to the touch. That heat should be going out the vent, not radiating off the cabinet. If it's warming the room, it's not leaving the house. Sign 3, a faint burning smell. Hot lint has a scorched, dusty smell before it ever flames. And sign 4, the one you can check in 10 seconds. Go outside while the dryer runs and hold your hand at the exterior flap. You should feel a strong, warm gust. If it's weak or the flap barely lifts, your duct is packed. Some setups are riskier than others. That flexible foil or vinyl hose, the ribbed, bendy kind, is the worst offender. Its ridges grab lint, and it crushes flat when the dryer gets shoved back against the wall, pinching the path shut. And the longer the run, the more places lint can settle. A dryer vented up through the roof, or pushed through a long twisting path to reach an outside wall, gives that fuzz far more room to pile up and far more bends to catch on. Same failure, just faster. So the question is no longer whether it can happen. It's how you stop it. Now the whole chain comes apart in your favor, because every link breaks with one thing: airflow. Keep the air moving, and the element never reaches 550 degrees. So here's the fix, in order of how often you do it. Clean the lint screen every single load, not most loads, every one. That's your first and cheapest defense. Then at least once a year, clean the full run. The flexible hose behind the dryer, the duct inside the wall, all the way to the exterior flap. That's where the hidden buildup lives, and that's what a screen can never catch. Next, upgrade the path itself. Swap that ribbed foil or vinyl hose for smooth, rigid metal duct. Metal doesn't snag lint the way ridges do, and it won't crush flat when you push the dryer back. Fewer bends, smoother walls, less to catch. Finally, confirm it worked. Run the dryer, step outside, and feel that exterior flap. A strong, warm gust means the air is leaving, which means the heat is leaving with it. Do those and the element stays in its safe range. The coil can run as hot as it likes, because the airflow is always there to carry that heat away. No trapped heat, no 550-degree surface, no ignited lint. The failure never gets started. So the chain is simple. A clogged vent traps the heat, the trapped heat drives that element toward 550 degrees, and the superheated coil ignites the packed lint. One blocked path, 4 steps to disaster. And the whole thing turns on airflow you can check with your bare hand. So do it today. Run the dryer, walk outside, and feel the vent. Next time, we open the wall on the thing quietly heating up behind half the outlets in your house.